Hey everybody, this is Larry. I'm doing this problem as part of a contest, so you're gonna watch me live as I go through my dots as I'm coding. There'll be an explanation near the end, and for more context, there'll be a link below on the actual screencast of the contest. How did you do? Let me know how you do. Hit the like button, hit the subscribe button, and here we go. That's pretty much
Okay.
it. Q3, find two non-overlapping subarrays each with target sum. Yeah. So this one, I think I spent a good amount of time just reading it as well as you kind of see here. So the thing that I was trying to figure out is just well the non-overlapping part. I think that's the quickest part. Um, the thing that I looked at was okay, what is n? Can we do anything brute force? Well, n is 10 to the fifth, so you have to do something in linear or n log n. And then the second thing I look at is target is positive, right? And what that means with target is a positive number means that well, then you could do greedy with a sliding window, and that's what I did here. That's what I start by doing. Or start doing. Um, at first, I was just gonna keep track of all the lengths and then just like pick the last two. But I knew that I didn't need to do that. But I don't know. I mean, it's just template or like mental putting it there just in case I need it later. But here I am doing the sliding window for each write, and you could have done this with prefix sum is the same thing. But when you basically with the sliding window is trying to find the invariant for targeting. And basically, when you process an element to the right, you can add that number to the current segment. And then if that current segment, the sum of that current segment is bigger than the target, you can subtract it from the left until it is either equal to or less than the target. And you could do this because target is positive, so that that condition will always hold. Otherwise, you might have to do some dynamic programming version of it. And yeah, and just moving the indexes obviously because I always forget it. But yeah, now this is the fun part. And then what happens when and there you go to target, right? Well, I was like, okay, let's just put the segments in there because I was by the time I typed this, I was like, okay, you have all these segments, and you want two of these segments that are not overlapping, and then you want the smallest version of those, right? So that's what I'm trying to do here. Mm. By the way, if you're still watching this, note that there's a full description at the link below, so that you can explanation with a link below. So definitely check that out if you're impatient for whatever reason, which is fine. But for now, I'm going to talk about my thought process and not necessarily the solution. Because for me, I think it's interesting or possibly interesting, maybe not if you're fast forwarding, kind of my thought process. And here, I just wanted to print out um, I just wanted to print out the segments just to make sure that I was okay with off by ones and stuff like that. And it looks like I was okay. So I was like, okay, let's jump to the next step. I was trying to keep mins. I was trying to be a little bit not clever, but I don't know if it made sense. Now I'm trying to think. Let's say we process the segments one at a time. What does that mean? And I was like, actually, we want to process them from left to right. So that means that I want to process the events anyway. Um, so then now this is what I do as a sweep line algorithm. Um, and basically it opens on the left and then it closes on the right, and then you do some processing on the left and the right, but I actually messed this up a little bit as you will see. um, I mean, so right now I'm thinking through what are the cases. You have to sort it first, but I really should have spent an extra minute thinking about it, to be honest, because I end up with two wrong answers because I wasn't really clear about how I wanted to implement it, or at least the edge cases that I want to. At this point, about 10 minutes into the contest, I was very much rushing it. I thought that I had to be a little bit faster, though. In retrospect, I didn't need to, but I was feeling that pressure. And this is wrong. This is just if there's no more segments, we do the delta thing. Um, I don't know why I thought this was correct, but basically what we want to do is we want to handle the left endpoints and the right endpoints in a different way. But what I was thinking was like, okay, when the delta is zero, meaning when we're no longer in any elements, then maybe we can process the minimum in some interesting way. Um, and I think that the rest of the idea makes sense. It's just that I don't know why I, and sometimes when you're wrong, you don't know why in retrospect. But you, especially with these algorithms, which are a little bit, I wouldn't say greedy, but greedy in nature in the processing. Especially with sweep line, it's generally going to be greedy in that way. But yeah, but this is well. Somehow though, unfortunately, it matches the answer from the results. But there are a couple of things I have to do. I have to check that it is. If it's not possible, then return -1, which is the infinite number. But I also have an off by one somewhere. That's all. Mostly that I was checking delta and not the current, which was wrong altogether. Um, because that never gets called as a result. When the code it looks still wrong, and I was like, huh. And it turns out that I just had an off by one because my right. I mean, you'll see me fix it very quickly. This is not a trivial thing. It's just an off by one because I was like, oh, yeah. My because I do right minus left plus one, but right is already exclusive, so I didn't need that case because I add one afterwards. Which is sometimes tricky to catch, but I mean, I knew that that was the case, kind of. I knew that that's a possibility, but I wasn't sure that that was the only bug, and that's why I'm hesitating right now. And that's why I just want to print it out just in case. Because I was like, oh, 0 to 1, that's exclusive, so we definitely need to fix that. I was also thinking whether I should just put the right later, but that's fine. But yeah, so now that looks good, which is a little unfortunate because that's why I submitted it. But I still had a, I don't know. I think I was just not care. I mean, to be honest, I was just really, just like some of it is jet lag. That's my excuse. I'm sticking to it. But also some of it I was just careless because I was rushing it. I really wanted to get a high score, if you will. And when you rush things, sometimes you like I definitely could have tested this case, and there was another case that I could have tested that was very much obvious, which you'll see in a little bit. Spoiler alert, but off by once. But yeah. But basically, because I had an off by one, well, not off by one. It's just that so the first one is just this is actually just wrong. It wasn't off by one. It was that basically if I have overlapping things, but or better if I have A that overlaps with B and then B that overlaps with C, C does not process the number in A. So that was the problem that I was running into. But and yeah, I don't know why I thought that that would work. To be honest, this is one of those things. But that you know, proof by AC. And then now I'm like, okay, if the delta is -1, meaning at the end of a segment, then we can do it, right? And that's just kind of, um, I test this, but I should have tested more cases. But like I said, I was rushing it. I was hoping to get a good high score for my friends out there. But that I click on submit before I really test some basic cases, especially after one wrong answer. Getting one wrong answer, sometimes I'm okay with it, but getting two wrong answer is me not not being responsible, like not being a responsible person. I am responsible for it, but because I was like, okay, this is such an obvious case when you see it too, right? It's just literally, and that's pretty much what I do for the next 5 minutes. I actually resolved it. There was actually an easy way to fix this, which is by, and I go over it in the explanation later. But which is that I had to treat the beginning segment and the end segment differently. But I was just rushing it. I was just I was just trying to get an answer because I knew that I was close, and I was close. But when you I think it's just a mindset thing. When you're like 95% of the way there, the last 5% of the way, you're like, okay, let's just do whatever works to get the last 5%. But sometimes you need to make sure you get that last 5%, and I didn't do that, and that's why I got two wrong answers, and it was really sad. As you can kind of see me being a little bit frustrated in that regards. But yeah. And now I'm just thinking, like, can I hack this? And the short answer is yes, um, but I I think I had in my mind that those two things have to be together. Um, and then I was just like, okay, let's reboot how I think about this problem. The sliding window is correct, so I didn't need to fix that part, but I just need to handle the left and the right in a better way, and that's what I end up doing. Still thinking it through. Like I said, I was still trying to think, but I wasn't really clear about it, to be honest. But yeah, but now I, instead of trying to figure out the left segment, I was like, okay, let's just for each left segment, we just keep track of where it begins, and then we only process the left part when we get rid of it, right? When it no longer overlaps it, or possibly overlaps with the current going from left to right, then we can track it or we can use it. So that's basically what I do here. The idea is that, okay, once we increment left past that, then we know that we can be like, okay, whatever's in there, it could be the min segment. So let's put it in there, and that's what I have the min for. But yeah, and the right minus left is just the segment that's inside. So yeah, I ran it. Oh, yeah, I forgot to. I guess I've deleted earlier. Hmm. Yeah, it looks okay. I mean, it looks wrong. So I was like, oh wait, that is still wrong. What is going on? Oh man, the good old print statement. Like I usually say, when if you have to debug during a contest, it's always a sad thing because you never want to debug. It always takes way too long versus coding. But sometimes when you need to, you need to. Has to be on the right. But yeah, the short answer is that there's just an off by, or yeah, I set the. I was putting the left and the right in the same thing, so it didn't make sense. But yeah, and also right is exclusive, so I fixed the off by one. So that basically your right would put in like, okay, this is the segment, and then when the left gets processed, then we're like, okay, this segment is actually good. That's basically what this is trying to do. And I was like, still okay. At this point, I was not confident. Obviously, after two wrong answers, it's hard to be confident. But I was like, okay, let's just try this, and really quick, fingers crossed, and then I get it. Q3. Find two non-overlapping subarrays with target sum. So this one was a very tricky one for me. Mostly just by off by one errors, or not off by one, but I had an idea on how to solve this, and I did it two different ways by accident. Yeah, and I spent 10 minutes debugging, which is kind of unfortunate. But the idea is that, well, the first part is just sliding windows, right? And then from the sliding windows, you just look for the target equals to target. The first thing to note is that target is between 1 and 10 to the 8th. But the key thing from that is that it's positive and it's not 0. So therefore, one sliding window processing it's good enough because you could do it in a greedy way. So that's how I did the sliding window part. And then the overlapping part is a little bit tricky the way that I did it. And I end up just tracking the minimum. I could have done this a little bit differently with like a heap or something like that, and this would make this a lot space efficient, though time a little bit slower. But the idea is that for each element, if this is the left part of us, so basically how I would think about this problem is you have some overlapping segments, and you might have seen how I tried to attack this problem earlier as a result. But basically, you give it an array, and then now you convert it into segments that or subarrays that have target equal to sum. So let's say these are both 3s. You have 1 to the 3, and then you have 1 1 2, and then 2 1, right? So you have all these overlapping arrays. The thing that I was trying to do in this problem is change it to an event-based system where, okay, so every time a full segment is finished, we put it into, we count that as a possible candidate for the min, right? And then we just keep on doing that. So for example, here the min is 1, here the min is 2, but then we throw it away because it's not min enough. Here it's 1 again, or 2 actually, sorry. And this is 3 because, yeah, it's inclusive. So this is 2. So then here it's at 2 elements plus the previous min, which is 1, so that's 3. And here again, but this one, here, we do not I think I had an off by 1 error now that I think about it. But we do not pop that yet until the very end, until this element is processed. And then now once that element's processed, then we can, we can use it. So for example, let's say, I'm just making up examples here now, but let's say, you have something like this. These are all overlapping segments. So now you process this is the min. Here, well, here you process this, but then here you do not update the min yet because we do not process the right endpoint yet. So we're going from left to right, sweeping line. So here it goes, okay, that's okay. We started at the beginning of a segment. Here we begin of the segment. And here we end the segment, though I think you have to do this one first, so it doesn't end it. So here it begins a segment, and here it ends a segment, and then this updates min here, which is, I don't know, 4 or 5 or something like that, right? So it updates the min, and then when we go to here, it also updates the min because this segment is smaller than this segment. But then here, but let's create another segment so we could illustrate a little bit better. But let's say we're up to here. Well, now we can check the size of this segment times plus the min, because here we know that everything that's already updated in min already contains the minimum segment, and here we just check this segment, like this segment plus a previous min segment is good enough. So that's what this is saying, and then here, oh yeah, right here, that's okay. We update the segment. Let's move this a little bit back. So then here again, when we get to this point, we update the min again. And then here, we take the min from this segment and the smallest previous min segment. So that's basically my algorithm here. Basically, we have a sliding window and a different thing to process for the left endpoint and the right endpoint. I think yeah, I don't know why I didn't really think about it that much. I think the way that I did it the first time is right. It's just that I was trying to merge two things at once. So how I would have redone it the way that I did it was actually with the two events, say. So this is okay too, obviously. But if I had given a chance to do it again with the event stuff, and you even see the event array, but we append the left, one for increasing the segment, right minus left. This is a little, and then the right. So we have something like that, and then now we have events.sort, and then for was it x, though we never use it, delta, and then segment or size in events. We can do, well, if delta is equal to +1, which is the beginning of a segment, well, what do we do when we enter a new segment? When we enter a new segment, we go, okay, let's take the ends is equal to min of ends, the current previous min plus the size. And then if delta is equal to -1, well, then we get to update the min. And that should be good enough, but and this is n log n versus O of n, it would have been with the other one, but it's still so much cleaner and so much less error prone once you really get to understand what it's trying to do. I'm not going to submit it, though actually I guess I should run this example test. I'm not going to submit it because the contest is still going on and I don't know what happens, but I'm relatively sure this is right now that I understand it a little bit better. I think in the contest, what happens sometimes is that, for me, is that you really want to get a high score, and then you rush through things, and then when you rush through things, you miss miss it a little bit. I was trying to combine these two things into one place, but I didn't really like. I had the idea in my head of what I like. I knew that I had to solve this problem, but I didn't really visualize this well enough to be like, okay, on the left endpoint do this, on the right endpoint do this. What I did was that I just was was trying things out until hoping that it was okay, and that's how you get two wrong answers. And was it 10 minutes of penalty on this one, where if I just stood back and really think about it, I could have gotten this trivially, and instead I did that other thing. But yeah, but that's all I have for this problem. The way that if you do it with the defense basis and log n, because you have to sort, though you could maybe do a little bit clever with the way you insert things, because you're going left and right after all. But of one space, so that's, oh no, sorry, I lied. This is of n space, because for each n there's yeah, for each n well, it's up to of n space, but yeah, for each target, I guess it could be of n. Or for each target, there'll be O of 1, so there'll be O of n possible targets, because, for example, you have just all the numbers are the same. But yeah, and you could have reduced this to O of n as we did before. For the running time, the space would be the same. Cool. This is a really tricky problem, at least for me. There's really a lot of places for potential off by ones, especially when you try to rush it. Definitely when you solve these problems, make sure you get it right. Getting it right is faster, faster than getting it fast but wrong, right? Obvious, but still, I still make that mistake from time to time, right? So yeah, that is Q3. Definitely good practice. I like this problem, actually, to be honest, even though I got two wrong answers. And it's not too hard, it's not too easy. You just have to really think about the edge cases and how to break down a problem, because they're, in a way, you're solving two different problems in one problem, and that's where the difficulty might come in. Cool.